on Cassandra. This is one of the topics that had been suggested before. I feel like we can talk about it today. Always welcome new organizers. Organizing means talking to people, reaching out to people. We don't really need sponsors now, but sponsors are always welcome. We're a diverse community from various backgrounds. Would love to get people from different backgrounds to talk. We're part of a much bigger group of meetups. In fact, I need to, and I'll do that now. We added a few groups apparently since the last time I updated our deck. See who else do we have here? So we got Nova, full stack. I think this is, I don't know what that one is, but I'm just going to go take a screenshot of it. And I'll update our deck here. And they don't like me. All right, here we go. We talk about Cassandra, all things Cassandra, things related to Cassandra like Spark and Kafka, or Cassandra.Like databases. See if there's anybody new. No one new today, it doesn't seem like. If you have a question, ask it on the chat or just contribute to the conversation. Speak Light, DataStax is one of our partners and supporters, so is GW, and a few people around the DC Chicago area. Thanks again to our organizational sponsors. They're actually helping us market Data Week DC. Any announcements? Anything new coming up? Okay. Our videos are all available on YouTube. Just Google Cassandra Lunch or go to YouTube and search for Cassandra Lunch. Our Cassandra.Link website is updated on mostly daily basis. If there isn't any new curated content, a new edition does not go out. We're working on a new newsletter to come out soon with jobs and curated content. So sign up for the newsletter. Also, fun fact, our newsletter, our website is a column on the DataStax developer newsletter, which goes out every 2 weeks, which is also a good one to get on. DataStax has weekly workshops. We have another one coming up in November 6th, I believe. But it's still being worked on our end in terms of content. It'll be on Spark and Kafka and Cassandra. It's the third in a series of event-driven toolkit around Cassandra, Spark, Kafka. Of course, we have our weekly lunch calls, like the one you're on right now. All right. Again, these are some of the events coming up tomorrow. Anything else, please, that you want to mention?
Nope, I think that about covers it.
Great. All right. So let me see if I can zoom in here a little bit more. I think if I go here, I can zoom in. Yeah. Okay. So the topic came up before, Lucene Based Indexes on Cassandra. I actually added one more topic, which is, how to use Cassandra with an external index. And we can talk a little bit more at length. So Cassandra plus external index. And there's different ways to do this. And we can talk a little bit more about that soon. So Lucene is a really old technology. It's been around. Let me see when the first Lucene paper was written. The first paper. Oh, now there's many more Lucene papers. But Doug Cutting, who was also the inventor of Hadoop, was one of the first people to basically, write about Lucene because he needed an index. And looking, this guy is Doug Cutting. So our guy is the chief architect at Cloudera now, who has basically consumed all the Hadoop companies. Let's see, he worked at Xerox PARC, where all the GUI technologies came out of. But eventually, when he was working on different search engines like Excite and Yahoo, he started to create technologies to do basically the job of creating and managing index. In fact, Hadoop was actually created to copy Google's idea, and he did that while he was at Yahoo. So just a little bit of lore, where all this technology comes from. Let me see when, the first Lucene paper, 2000, right? About 20 years ago. So it's quite a journey for Lucene itself. What is Lucene? Lucene is a NoSQL database. That's how I see it. And what I mean by that is it's a document store, essentially. And let me see if I can find a picture of the Lucene data model. There we go. And what happens is it creates these documents. It breaks the document down into tokens, and it stores essentially where that token is and in which document. It stores it in a basically a radix sort hash table, and that hash table is what gets put into disk, and then that disk continues to, like in Cassandra, it creates new files that eventually gets merged back in, and it's basically just like Cassandra, right? Document goes into memory. It also goes to the log, creates these new segments, which has these, where in this document, where does that particular segment sit? And it says, okay, this is the value, this is the, and then you can have your own fields. You can define any of the fields that you want. So in this case, it's just a key value, right? And then every now and then it gets merged. You can read more about Lucene, and basically it's a database, because when you create a new object in Lucene, you say, here's what I want in my document, and I want to have this field with this field type, and I want to have this field type with this other field type. And there's basically two types of analyzers that are used to interact with the index. There's an index time analyzer and there's a query time analyzer. An index time analyzer is when I give this data, how do I break it apart into the tokens, and how do I basically consume that piece of data? And then there is a query time analyzer, which is when I query, which query parser is that, let's see, how to take a query that I'm giving, and how do I break apart the query, and then how do I look for this information? So when you add something to a document, you can say whether I want to store this item or whether I want to index this item. And you can store it and not index it, or you can index it and not store it, or you can do both. What does that mean? When you store it and don't index it, it just stores a value like a database, but you can't query on it. If you index it and you don't store it, that means that you can query on it. It'll tell you which document or whatever you have. It'll retrieve what is stored, which is at least the document ID, and eventually be able to get to your information. People actually use Lucene as the actual storage. So like, Solar, people use it. They put data into it and they retrieve it. Or Elasticsearch, they put data into it and they retrieve it. But for the most part, if you're building a search engine or if you're building a resilient search system, information retrieval, as it's called, you need to have data stored somewhere more robust that then gets indexed into one of the Lucene indexes. So Cassandra happens to be one of those databases. And, you know, way back before Dse Search was a thing, somebody made a thing called Cassandra, and Cassandra was one of the first projects which, not the flower, Solar plus Cassandra. And what this did was basically store the data for the index in Cassandra, but it still had index files on disk. And this code eventually became what is Dse Search. So if you want to take a look at the original Dse Search, 7-year code that's about 7 years old, you can take a look at this. Another pattern, and this is what we used to do for Appleseed Search, is we would store data in SQL Server as an intermediary database, and then we would take all of the data and index it into Lucene, like raw Lucene. And when we did a search, we would know what document or what item ID or whatever we need to retrieve, and then we would get it from another database. So it's a common pattern to use Lucene as the index, but then to use something else as your actual resilient data store. Anybody that's in the search engine business knows this, that you don't trust Lucene or Solar or Elasticsearch as your end-all be-all data storage, because it gets corrupted sometimes, and it's not really like a real-time, even though it has real-time indexing and availability, like it's definitely not a transactional system, okay? And it can be used for analytics because you can do a lot of cool queries on Lucene, but at the end of the day, it's really not supposed to be a database, but people can use it as a database. And at least the Solar project wants to make Lucene a database. They even have like SQL on top of Lucene, and more power to them. They can figure it out great. But Lucene has got a history. It's great technology. It's probably the most popular index technology in the world. I gave a talk a long time ago. In fact, I'll refer to it just to give you guys some context. That Lucene also powers things like, Amazon's cloud search is powered by, at least the last time I checked, it's powered by Solar Cloud. Azure's cloud search is powered by Elasticsearch. And basically, unless you are Twitter or Google or Facebook, and I think even LinkedIn uses Lucene elsewhere, you don't need to make a new search index. A search engine is more than the index. It's the how do you get data in, how do you get data out, how do you manage these indexes, how do you do ranking. Lucene is just a way to put the data in there and retrieve it. Any questions about just basically Lucene? What is Lucene? Why do people use it? Okay. Actually, I found a document by Yannick. Yannick is one of the committers for Solar. It's slightly older, still relevant, but basically, it is an inverted index where the word that's the index storage. It tells you then what documents it's pointing to, and then there's a new thing called doc values, which I'm not going to get into. Data gets parsed at index time, put into the index searcher at query time, gets the data. That's what all Lucene does. These files get merged, just like compaction, as I mentioned earlier. There are different tokenizers, and there are different parsers. So, what are some other technologies that work with Lucene? Nudge is a large-scale Hadoop-based crawler that puts data into DFS. Solar is the one that we're going to talk a little bit about today. Again, this is a very old document. It has, I think it even has CSV APIs, but basically it's got some infrastructure around it. So going back to the Cassandra world in a second. Any questions about Lucine or Solar?
Yeah, I have a question. So if you're indexing with Lucine or Solar and your storage backend is Cassandra, the indexes, they're getting stored in something separate than a Cassandra table, or like where do the actual index data get stored?
In which technology?
For like, yeah, like say for if you have Elasticsearch, like say for like Cassandra, for example.
Okay.
Is it different per like Cassandra? Is it different than Solar? Okay, I see.
Yeah, all of these are slightly different. Yeah. So in Cassandra, what happens is Cassandra sits beside Elasticsearch, right? And then the underlying technology, what it's doing is it's taking mutations to Cassandra and it's turning them into mutations to Elasticsearch. I think it can even do, I think it can even do a table schema changes and things like that. If I remember correctly, the way it does this is also similar, but I have to double check. I remember reading something that there's actually one way that data is mutated in Cassandra, and it eventually goes to both. Let's see, I think I can find it. I'm sorry about that. Yeah, it seems like basically it does both ways, and I'd have to double check. But basically, it's, the read writes are going both ways. I want to say updates are indexing Elasticsearch. And adding data to Elasticsearch. Yeah, I don't know exactly how it goes from Elasticsearch to Cassandra, but I know that it's first it goes to Cassandra, and then that mutation, it basically goes and changes it on Elasticsearch. I can get back to you on that one.
I guess my question is like, does it double your disk space use? It does. Yes. Okay.
It does, and in this case, I think in the pro version, I don't know, but at least in Cassandra, my assumption is it's going to double it, because I want to use it in both ways. I'm going to store and I'm going to index in Elasticsearch versus just storing here and indexing here. You get where I'm coming from? Because I want to use this as a REST API, at least in the way that I'm going to use it. I want to see the data too, right? I just don't want the reference to the data. I want to see the data. If you use the enterprise version, I think you can do something where you can do CQL statements with arbitrary queries where it translates them into Elasticsearch queries in the back end, and I don't know if it has to store it. But yeah, in this case, my assumption is going to do it twice, unless you specify, I don't want to index this, or I want to index this, or sorry, I want to store this. I don't want to store this. In the Cassandra Lucine index, it's different because there's no service. So it's mutations to Cassandra become mutations on disk. Right? It just stores those files for that node. like a secondary index works. It just stores it on that particular node. Whatever data is on that node is what is getting indexed on that node. So this is useful, except if you don't know your partition key, you're going to go to each of the nodes. I have to check if it improved, but let me find it. It's the Cassandra Lucene index. By the way, I'm going to save these resources for people to look at later. And as you can see, this is no longer maintained. I believe maybe InstaCluster may be maintaining a fork of it. But yeah, it basically stores it on that node. So it's not a distributed index like Solr or Elasticsearch, where it kind of knows where all the data is. It basically, you have to go to each node and look for that information. So this is, let me see if InstaCluster has something that's further along. Yeah, so it looks like they're continuing to do this. There we go. Hey, that's our website. Great. Yeah, so now they're maintaining it, right? So that means that you're not going to be SOL if you decide to use this. Yeah, and it's a plugin, right? You add it on to that Cassandra node. You have to give the data. You have to add that Lucene jar. You have to add that plugin into each node, and then that's how it works. Any questions about this one in particular? So there's a few other versions, a few other ways to do Cassandra plus Lucene. As I mentioned, like Solandra is one of the old ones, which became Dse Search. Dse Search is it's basically Cassandra and Solr together. The way it works is you make a table, and then you can turn on that table an index, search index. And this is different from like a SASE or a SAI or whatever. And when you configure it, here, you can customize that schema as you would customize Solr. So you can say, I want this thing to be indexed also. It's assuming that it's not storing it in Solr because it's already stored in Cassandra. But if you wanted to say stored equal to true, then it could do that too. Why would you want to store it? Well, if you want to do a retrieval and have highlighted results, then Solr needs to have that data in there. It has to store it. Otherwise, it's not going to be able to basically store the location of that token so that it can show you a highlight, for example. And it automatically generates an index, but you can change it. You can customize it, and you can configure it. Here are all the different ways to customize it. So let's see. This is just the creation of the index, and then here you can update. Let me find the field specific. There's like a field specific list of And you can make these changes using CQL and your Solr config file. And each table, right, has its own Solr config file. Most of the things that you can do in Solr, you can do with Dse Search. Mind you that it will be using a slightly older version of Lucine and Solr, not necessarily like the newest, wildest version. And then there are some limitations on this as well. Dse Search is probably the most widely used next to Cassandra Lucene Index. It's supported, and then Cassandra is a relatively new technology, so I don't necessarily know if it's like beyond 100 or maybe even 50 installations for this. So in terms of scale, I've seen Dse Search scale pretty well. Cassandra Lucene, I think people have used it and then they end up not using it because it doesn't do what they expect. Because it's, you have to still kind of look at every node to figure out where the data is. It may not necessarily work for you. Cassandra is very promising, but again, based on conversations with customers and, there's just not enough of an adoption for them to commit to using Cassandra. That's really the only major drawback. Oops, wrong one. So this is kind of the packaged, right? I'll just say it's packaged way of doing it. But there's also a do-it-yourself DIY, which is Cassandra plus an external index. What generally transpires is somebody will use CQRS and an event/command goes into an event source repository. Sometimes it's Kafka. This could be a SQL table, etc. Right? Then the processor, the command processor, it processes into CQL and into Elasticsearch or Solr or Amazon, Algolia. I mean, you name it, right? But on the request side, this is on the right. On the request side, it's not really going, first to CQL. What it does is that event command goes into an event source queue like this. Command processor goes to Solr or goes to index, finds the data, goes to CQL or Cassandra, gets the data, returns it. Now, you don't always have to do this. If you store your data in the index, alternatively, you can just query the index. And CQL is just there as your resilient data store. This is really just one way to do it. It's a industry best practices for keeping different systems in sync. It's not just for keeping Cassandra and Elasticsearch or Cassandra and another index in sync. It's just the way to do it in real time. Another way to do this is, just batch index. You do your reads, writes to Cassandra normally, you do writes to Cassandra. Every now and then you index to whatever, outside index. How? can be done using Spark, actually. It's one way to do it. Another way to do it would be Cassandra triggers. Cassandra triggers are not available on all of the different versions. They're really available, I think, on 3 and above. But it's not like a SQL trigger, like you have to program something. But basically, a trigger is executed after it's in the commit log and it's about to make the mutation. So like before it actually makes the mutation, meaning the change. And you have the data as it was before and as it's about to be. And you know, at that time, because it's Java code, I don't think you can do, yeah, I think it's Java or Scala. You can, any JVM language, you can make a trigger. You can even do it in Kotlin or Groovy, as long as it compiles into, you know, Java. You can essentially write to an external system, meaning if it's Solr or Elasticsearch, it would write to that REST endpoint. It would probably scale okay if your Solr Cloud or your Elasticsearch or your external Lucene is scaling, it would probably scale fine. But it's a little kludgy. There are companies that make software on top of Cassandra and they need Elasticsearch as an indexable data source. What they do is they'll make a plugin and they'll invest a lot of time and energy into it to basically make that trigger configurable. So it would work with any table. So this is, you know, one way to do it. Another way would be Cassandra and it doesn't necessarily have to be, I'll just say Cassandra CDC, change data capture, which is, again, only available in 3 and above. When you turn on change data capture, it creates files that you can actually read, not just commit logs that are like binary. And you can take these CDC change data capture raw data and do whatever you want with it. You know, you can read it, consume it, and index your data. But there's different ways to do that. So you can do CDC to Kafka Connect, and then from Kafka Connect to Cassandra. You could also do CDC to Kafka, and then you have your own indexer / Kafka consumer that then sends it, sorry, wrong one. I didn't mean to say Cassandra, just say index here. Right? Kind of like showing you how it all ends up in an index eventually. CQRS is basically Cassandra or event goes to CQRS, goes to Cassandra plus index simultaneously. You could also have, let's say, serverless function, which then writes to Cassandra plus index. It's essentially this, but somebody else is managing your event. You just take care of the logic. What are the pros and cons of using Lucene? In any of these scenarios, right, do-it-yourself or packaged, you have to understand that Lucene is, two pros first, extremely rich search capabilities. I'm talking like geospatial, let's see, synonym, fuzzy logic searches, typos, yeah, stem, it has stemming. I mean, you name it, it's pretty good. It's not going and doing a really dumb, this like percentage sign type of thing. It's a real search engine. It's really powerful. Cons is that if you're making your own, like with pure Lucene, okay, if you're doing this on your own, you're reinventing the wheel of what Solr and, let's say, Elasticsearch. Okay. Oh, I remember one more. You can have something like Apache NiFi take events. Guess what? NiFi actually is powered by Lucene. And then your NiFi processor can then send it to Cassandra plus some index. NiFi can do a lot of cool things, and it's very, very fast. And I actually remember these guys who built it speak at a Solr user group right before they basically got subsumed into another company, and basically, I think they work for the NSA now, or they used to work for the NSA. I don't remember exactly, but great technology. So the thing with pure Lucene is that you're reinventing the wheel. Really no reason to do it. Another con for, let's say, Elasticsearch, external, to say external Elastic / Solr / whatever, right? Is that you have a latency between finding the data and then getting the data, okay? But you can get around it, right? You're going to do a search, you get your doc IDs, and you do a client-side join to then retrieve all your information. That's one way to do it. Another one would be built in, so packaged, Elastic / Solr. Well, the one I know is Lucene. Is that, well, it's a shorter latency. Maybe so I'll just say inside this, there's a shorter. This is a longer latency. I don't know if there's really a con here. I'll just say, don't expect it to solve all your problems, because if you don't have a good data model, wide partitions and skew is still going to kill you. It doesn't matter if you have an index on there. So just watch out. Oh, always consistency issues if DIY, always an issue. We have a client that's using Dse Search, except for a consistency issue, which we helped to resolve by adding more resources. They wanted to completely rebuild it on like Dynamo and Elasticsearch and Kinesis and Lambda functions, and basically implement this with, a Kinesis in front of it. And I was like, you know how much time it's going to take to build this solution that will work with any Dynamo thing, and to test it and do all this stuff. And I think they understand that it's a lot of work. And people can do it. Amazon probably has built their whole search for their catalog on this. That's fine. And I have nothing against Amazon. I'm just saying any scenario where you're rebuilding this consistency engine, that's where you're going to hit the problem. If you look at Cassandra code and if you look at Solr code, which is both open source, there's a lot of work that has gone into making things consistent. A lot of work. In fact, that's literally what Cassandra does. It's a consistency engine. It keeps replicas for you. And so what happens is when you start doing this on your own is that you're going to end up having Cassandra replicas, which have sometimes their own issues and have to be repaired. And then you have your other system that you have to keep, quote, repaired in sync. So there's a lot of maintenance for anti-entropy that then you have to do on your own, which is all possible. If you have a good distributed log, like Kafka, then basically, you know, you can replay and replay and replay and make sure everything is consistent. Other cons is that Lucene is memory heavy. Lucene is disk heavy. So if your data for the Lucene index is on the same drives as your Cassandra data and your commit logs, it's going to slow down. In fact, that's one of the things we helped the customer see is that they were having commit logs and their data for Cassandra and their Solar data on the same drives, and all of them are getting simultaneously bombarded. Well, yeah, sometimes Solar's going to crap out. Sometimes Cassandra's going to crap out. It's a race condition on the disk. So when you have it in a separate system altogether, like if you do it, you know, where the things are detached, then you have the possibility of never running into that issue because they're a completely different system. So that's actually a pro if you do it yourself. So separate index means better separation of concerns and speed, right? So any questions on what I just covered last 10, 15 minutes?
Yeah, so regarding data modeling, you touched on it a little bit. You said, like, you know, your partition, if you have bad data model, your partitions are still going to be wide, you're still going to have skew. What does change though in your data model if you know you're going to use an index? Does it change, you know, your cluster? Maybe you don't need to use clustering columns as much, or what would you change going into it?
That's it. That's basically it. So like if you don't use clustering columns at all, then you're not going to have a wide partition issue, right? But if you're using clustering columns and you're doing an index, you're going to have a wide partition issue if your data model isn't correct. Partitions only grow, and well, you can always also have a wide partition issue if you keep adding like a bazillion columns, right? You don't have a limit on the number of columns in Cassandra, so you can keep adding new columns. So your partition could be fat, either like this or like this. It doesn't really matter. That's going to be an issue. But yeah, if you have a clustering column, if you don't have a clustering column, then every partition is a different row. So you add an index, and if it's using something like this, right? Remember that it has to go, just like in a secondary index, if you don't know the partition key, it's going to go to each node and it's going to look for it. So if there's 10 nodes, it's going to go talk to all of them. Because in this case, Lucene is not keeping some master index for you. At least in Solar, there's a way that it communicates with each other. At least in Dse Search, there's a way that it can delegate. Right? It's not doing that here. It's assuming that Cassandra is doing a delegation. So Cassandra takes it and says, okay, well, I know I don't have to do a really bad scan, but I need to go to each machine and ask for this data, which this doesn't solve your speed problem if you're going to talk to 100 nodes for querying something. So that's where you should be having, sometimes you should have a partition key and a clustering column and apply an index to it.
So you're saying you can have really skinny partitions, like you said it's okay now to have each row be its own partition if you have an index. Is that? Yeah.
Just be mindful that in this case, it's going to talk to all the nodes. And at worst case, it talks to all the nodes and gets you back one result. Best case, it talks to all the results and gets you all the results, which is fine. It found it. It didn't have to do a complete thing. Now, performance decays in less restrictive queries. As the number of records returned by the query increases, reach a point where the index becomes slower than the full scan. And they even talk about that here. I think this is what this is supposed to explain. Right, so you have a kind of a happy medium as to where this is actually useful. If your index query is going to be taking longer than a full scan, then it's not helping you anymore.
Right. So I guess I don't understand how that would work. If how does it avoid storing all of the data of all of your tables on one node? Because your partitions, if you have one row per partition, it means that normally Cassandra would store the data all over the cluster. If you're using indexing, how does it avoid still just having to go through your whole cluster and finding things?
Right. So this is different from Cassandra or Dse Search. What it's doing is if you index a particular column, it stores where that particular token is in which partition key it's in. So then it can get the partition key from Cassandra. You get what I'm saying? It's not storing the full record. In this case, it's not storing the full record. In Solr, in Dse Search, and in Cassandra, there's a different story. But when it goes to get the data, it has to first find the partition key for you, and then it goes to the Cassandra table, and then it gets the data using the partition key.
Okay, so just for Dse Search and Cassandra, how do they avoid storing all the data of all your cluster on a single node and still return the data without making you do a full table scan?
Okay, I got you. Yes, that's kind of the intelligence of Solr Cloud and Elasticsearch, because they were built as a distributed search index. That's in the logic of Solr Cloud, and it's in the logic of Elasticsearch. Is that I have to check at least with Elasticsearch, but Solr Cloud uses Zookeeper to kind of keep an understanding of where the index segments are. I don't know exactly how DataStax implemented that because they don't have Zookeeper. It might be that they actually store it inside Cassandra, the metadata on where the data is. So it's able to do what Zookeeper would have done by keeping the data. So like if you, I haven't seen that schema in a while, but if you go to the Solr admin key space in DSC, you can start to see if that has that information.
Thanks.
But I can get back to you on that. But I'm fairly certain that that's how the Solr. I don't know the answer of exactly how, as in code-wise, it's doing it. But I know that's a technology that's as part of Solr Cloud. It's part of Elasticsearch.
Okay, cool.
Okay. All right. In fact, here, this project is not intended to replace standard denormalized tables, inverted indexes, and/or secondary indexes. It's just a tool to perform some kind of queries that are really hard to be addressed using Cassandra out of the box, filling the gap between real-time and analytics. That's just kind of in the middle. Right. Awesome. So we're at the end of our segment today. Soon enough, we'll have some of the notes wrapped up in a blog post, as well as the video up on YouTube. Looking forward to seeing you guys next week, same time, same place. And actually, before we hop off, let's take a look at our backlog here. We've got Cassandra data modeling. We kind of talked about this. I think we didn't talk 100% about it, but we could definitely, I'll put that in the back right now. Cassandra data model, optimizing queries. We have search storage attached index, which is new. Cassandra for data analysis, data science. Yeah, actually, you know what? This would be good. We actually have some folks who've done some blog posts and videos on this too, so we can call them to give a presentation. This is a good one too. Any other kind of requests on what to cover? And there's a lot of stuff we've already talked about. All right, Cool. Well, we'll continue with our backlog and see where we go next week. All right, guys. Thanks so much for your time, and I'll see you next week. Bye.